Welcome back to SV Ramble on. So I'm back to messing around with the alternator mounting kit for the Perkins 108. Sent it back to Balmar. They sent it back to me. They said, well, this is within our machining tolerances. And if you remember from our old video, it was a couple of thousandths off. The inside diameter of this was too small to fit the crankshaft pulley. So what I had to do was I kind of rigged up something with some emery cloth and some adhesive tape and found a socket just about the right size and then wrapped a few layers of emery cloth around it and then ran the drill on really slow speed through the hole in the shaft to make it slowly sand it down. So there's the crankshaft sticking out of the front oil cover, and there's a keyway here, and after a couple of trips back and forth to the shop, that's how that thing's supposed to fit on there. Anyway, all I got to do is set the center bolt, torque it back down to, I think it's 150 foot-pounds, and then I can start mounting the water pump and the alternator, which is probably going to need the bracket modified as well. So let's now we get working on the rest of the stuff.
Alright, so once I got the lower crankshaft pulley sanded down on the inside to fit the crankshaft and got that thing fitted up, I dry fit the water pump to check pulley alignment, and the old alternator bracket has some adjustment slots on it, and you can move it forward and back a little bit to adjust the belt angle relative to the other two pulleys. The whole alternator assembly needs to move out about 3/8 of an inch, and that is from this point here at the back of these oval holes. It's bottomed out. So I got to do some modification to the alternator bracket, but also on the Balmar case, this works with a 1-inch or a 2-inch foot on the bracket mount. The problem is that's not actually 2 inches. It's about 1.94. It's about 194. My alternator bracket is just a little over, it's about 2 1/16 of an inch. So that was an easy fix with a stainless steel washer. There's a 1/2 inch diameter hole in there. So that was the easy part. So now the alternator sits on this bracket. This bracket bolts to the motor. I also got this. It works like a turnbuckle. And it's got two eyes that they have little balls in them that move. And just like a turnbuckle on your rigging, when you tighten and loosen these, they're opposite threads. So you can adjust it out or in, and that bolts to this arm of the alternator on the backside. What happens is you have to pry on it with a screwdriver to get the belt tight, and then you got to tighten down a bolt, and you almost need 3 arms to do it. So what this does is this hooks onto here, and then with a wrench I can adjust it till I get the right bolt tension and then tighten everything down, or excuse me, the right belt tension, and then tighten everything down. Because I'm going to have to weld a piece onto this old bracket and salvage some metal out of here and weld a piece of plate onto here, and then make these oval mounting holes need to be a little bit longer. There's 2 more holes that bolt to the front of the block. That's going to have to be shimmed out away from the face of the block by 3/8 of an inch to take care of that belt adjustment. So this piece is going to get tacked onto the back here, but I got to make a little notch. So what I did was grind a little groove in here so I can fill the bead of weld, and then I'll enlarge these holes to get me that 3/8 of an inch. I really only need to go to the back of the bracket. It'll barely be into the weld. And then I'll just enlarge those holes. I got some meat back here. Those magnets are pretty handy for holding things. Just a matter of connecting these 2 pieces of metal together with a little bit of high voltage electricity. I got this thing jigged up. Now let's start welding. So as you can see, I am no welder by any means. And now I can weld the backside. First, I'm going to do a little cleaning up on this side of the weld. So here you can see, after grinding it down, yeah, it came out all right. Not bad. I mean, it ain't pretty. Not bad for amateur, I guess. But now I need to fill in this side and grind that off. So now I got a good metal connection. This thing looks pretty tight. And then I'll just clean it up, make these bolt holes a little bigger. So I've got some forward adjustment on the alternator bracket. That's about that. And now for the front oil seal. And that's why I cut this little block of wood. That feels like it's seated in all the way. And then find the keyway. And I put a couple of wraps of duct tape around the wheel, around the pulley. One facing in and one facing out, sticky side out. And it seems to grip the Dacron rope enough that when I go, there's 150 foot-pounds of torque. There we go. So I got the holes ovaled out, and let's bolt this thing on and see how everything fits. This is the engine pick point. I've got my bushing to put the proper forward thrust on the bracket to make sure it moves set where it's supposed to sit. Put the alternator in. And one. Just snug enough to allow it some rotation and pivot. Grab the belt. Oh, that's pretty damn good. The face of the pulley and the alternator pulley, and also the crankshaft pulley and the water pump pulley. Those are square face to face. What I got here, it's a turnbuckle type thing, and now I'm going to put that in. This thing has threaded holes. It has 3 threaded holes and 2 unthreaded holes right here. One of the eyes has a bolt and a bushing. I had to put a bushing in it because these are 3/8 holes, and the alternator uses actually a metric. It's an 8mm metric, which is basically 5/16. It's not 5/16 threads, it's metric threads. I'll put the engine ground right here, and then this hole used to be 5/16, and I had to enlarge that. So the belt's still sloppy. Now all you do is you turn the center hub. You just rotate it out like a turnbuckle on your standing rigging. Puts actually an incredible amount of force on the belt. So now you can see the belt's getting tight. Once you get the belt tight where you want it, then you just spin these nuts up, and these nuts jam against the center turnbuckle and lock it into place. And there's a nut top and bottom, so you're basically sandwiching this little center, the center adjustment. And this thing here, this is the actual hose for the raw water, but I had to shut the seacock off and drain the raw water system down. So what I did was just stick this hose right here, and I filled it with water just so that it kept the raw water pump impeller wet. I didn't want the impeller to dry out during this whole debacle, sending stuff back and forth to Balmar and messing around with everything. So I've got to check. There's actually a specification on this serpentine belt as to how much deflection you get in the belt between pulleys, and they say something like, I don't know, like a 1/4 inch. If you can push a 1/4 inch on the belt, then the alternator tension's correct.
The Balmar alternator serpentine pulley kit installed finally. I did spritz a little bit of blue paint on the alternator bracket and the engine pig point. I did spray the water pump with a little gray primer.
Got a digital tachometer, but when I shine this down in, I'm getting weird readings. It's not 3,700 RPMs. In order to do the engine timing for the alternator feed to the tachometer, you put a little piece of reflective tape on the crankshaft pulley. It reads how fast the engine's turning. I wanted to see how fast the alternator was turning in relationship to the crankshaft, and it's somewhere around a 2.25 to 2.3, something like that ratio. That's where you get your calculations for the voltage, or the amps actually, at engine RPMs. You're actually reading the alternator speed. I put a little piece of reflective tape here, put a little piece of reflective tape on the crankshaft pulley. I was getting some weird feedback from the shiny surface on the pulleys. It says if the surface is shiny, it needs to be blacked out. So what we got right there on the pulley, reflective stripe of tape, and down here on the crankshaft, reflective stripe of tape. So, by painting this face black, and the face of the alternator pulley also, painting it black, and putting the reflective stripe on, that helped get a more accurate reading with the little digital tachometer here. I'll take those numbers and I can calculate how fast the engine RPMs are going. Once I get the alternator hooked up, there's an out feed to the tachometer. Based on the engine RPMs and the alternator RPMs, I can adjust the actual tachometer at the helm to read appropriately. There you go. That's that. So that's it for now. Stay tuned in a future video. We're gonna program, install, and wire up the external voltage regulator and hook up the charging system to the battery. So if you like it, give it a thumbs up, and if you haven't already, go ahead and subscribe. And feel free to comment down below, and if you got any questions or something you want to say. Thanks again.